presenting our project on fraud detection using business intelligence and analytics. Fraud Shield Digital Bank is facing increasing fraudulent transactions leading to financial losses and reduced customer trust. To address this, we developed an end-to-end system using Python, Postgres, SQL, Salesforce, and Power BI to detect fraud and provide insights. Project Python is used for data processing, feature engineering, and fraud detection. First, we load the transaction data set using the Pandas library and connect to a Postgres SQL database using SQL Alchemy. The raw data stored in the database ensured structured data management. Next, we perform the data cleaning to remove inconsistencies, handling missing values, and standardizing the data sets. After cleaning, we apply feature engineering to improve the analytical capability of the system. For example, we create the column called high value flag where transactions above 10,000 are marked as high value. We are also created a fraud flag and generated additional features such as risk level and fraud probability. The features help in identifying high risk transactions more effectively. The cleaned and processed data is then stored in Postgres SQL in a table called clean transactions. Next, we perform the fraud detection by analyzing the transactions pattern and assigning risk levels such as low, medium, and high. The final results in a table called fraud analysis, which contains all the important fraud related information. Finally, high risk transactions are exported into a CSV file, which is used for integration with Salesforce to generate fraud alerts. Overall, Python plays a key role in transforming raw data into a meaningful insights and enabling effective fraud detection. Here, Postgres SQL is used as the database to store and manage all transaction data. It acts as a central repository that connects Python, Salesforce, and Power BI. Here we have three main tables: raw transactions, clean transaction, fraud analysis. Raw transactions, which stores the original data sets; clean transactions, which contains the cleaned and processed data. That table contains data after pre-processing where inconsistencies are removed and new features are added. Fraud analysis, which stores the final detection of the fraud results. The most important table is fraud analysis because that is the one which has the output of the detection process. It includes the key fields such as transaction amount, transaction type, fraud flag, risk level, and fraud probability. These results help in identifying suspicious transaction and support decision making. Overall, Postgres SQL efficient data storage, fast querying, and smooth integration between different components of the system. Salesforce is used as the CRM system to manage and track fraud alerts. A custom object called fraud alerts is created to store high-risk transactions identified by the system. Each record represents as a fraud alert generated from the processed data. The records contains key fields such as customer ID, transaction amount, fraud risk level, and fraud probability. These fields helps in analyzing the tracking suspicious transactions effectively. Custom fields and validation rules are configured to ensure data accuracy and consistency. Due to API limitations, CSV-based approach is used to import high-risk transaction from Python to Salesforce. This enables integration between data processing and system and the CRM platforms. Salesforce allows the organization to monitor fraud cases, manage alerts, and improve response time. This FA001 fraud alert representing the high fraud risk, and FA003 fraud alert enhancing the medium one, and the FA002 enhancing the lower one.
So hi, my name is Kishore, and today I will be presenting the fraud analytics dashboard developed using the Power BI. So that this dashboard analyzes the financial transactions, identified fraud patterns, and highlights the high risk behaviors across different transaction types. So I will start with the unified main dashboard. So and then I will walk you with each transaction types separately for debit, deposit, payment, transfer, and withdrawal. So basically on this screen, you are seeing the unified fraud analytics dashboard. This dashboard provides a complete overview of the entire data set and helps us to understand the overall fraud landscape. So at the top, I have displayed 4 key KPIs. So total transaction, fraud cases, high risk transaction, and average fraud probability. So in total transactions, there are 762.12K count, and this represents the total number of transactions processed in the dataset. And similarly for fraud cases, there are 1977 cases. So these are the confirmed fraudulent transactions identified. And for high risk, it is up 12K. These transactions flagged as the high risk based on the fraud probability score. So the next is average fraud probability, which is 6.35% in average. This is the overall average probability of the fraud across all transactions. So next on the left side, we have the risk level distribution. This shows that a significant portion of the transaction fall under the high risk category, indicating suspicious behavior patterns. So on the right, we have the transaction type versus fraud chart. This chart compares each transaction type with the number of fraud cases. From this, we can clearly see that transfer transactions contribute almost all the fraud cases. So while the debit, deposit, payment, and withdrawal show zero confirmed fraud. So below that, we have the fraud probability by step. So this chart shows how fraud probability changes across different time steps. So we can observe certain peaks where this fraud probability increases, indicating potential risk periods. Finally, at the bottom, we have the recent transaction table. So this table summarizes the count, amount, risk level, fraud cases, fraud probability, and transaction types. So from this table, we can again confirm that the transfer transactions dominate both the transaction volume and the fraud count. So this unified dashboard gives a clear high-level understanding of the fraud distribution before we go to each transaction type. So now we will go to the debit dashboard. So for the debit, this is the debit transaction dashboard. At the top, we have again the 4 KPIs: total transaction, fraud cases, high risk, and average fraud probability. So you can see the counts. There are 340 counts in the debit, and fraud cases are almost 0, and high risk are 11, and the probability is 1.11%. This clearly shows that the debit transactions are very low in volume and have 0 fraud cases. In the risk level distribution, only 0.09% of the debit transactions fall under the high risk category. The transaction type versus fraud chart confirms that debit transactions have no fraud cases. So next, the fraud probability by step chart shows very minimal probability values, indicating that debit transactions are generally safe. In the recent transaction table, we see count, amount, fraud cases, and fraud probability. So overall, debit transactions show low risk and 0 fraud, so making them the safest category in the dataset. So next, we will move to the deposit dashboard. So for the deposit dashboard, you can see the total transaction is 202.34k, and for here also it is 0 fraud cases, and the high risk is 4240, and the probability for average fraud is 10.66%. So even though there are 0 fraud cases, the fraud probability is relatively high. So in this risk level distribution, around 34.74 of the deposit transactions fall under the high risk category. So transaction versus fraud chart again confirms 0 fraud cases, and the fraud probability by step chart shows high probability spikes, indicating that deposit transactions are more suspicious even though no fraud is confirmed. So in the recent transaction table, we see the count 2 lakhs 2,335 count, and for the amount it is like more than 59 something, and the fraud probability is 452.04%. So this is extremely high probability score, indicates that the model flags many deposit transactions are suspicious. So overall deposit transactions show high risk but 0 confirmed fraud, which is they require closer monitoring. So next is the payment dashboard. So here you can see the total transaction is 22.98k count, and for k here also it is fraud cases 0, and high risk is 345 level, and the average fraud probability is 1.04%. So payment transactions have low volume and low fraud probability compared to others. The risk level distribution shows that only 2.83% of the payment transactions fall under high risk. So the transaction type versus fraud chart confirms 0 fraud cases. Again, we go to fraud probability by step. This shows very low probability values, indicating stable and safe behavior. In the recent transaction table, we see the count again and the amount, and so the fraud probability. So overall payment transaction are low risk and stable, with no fraud detected. So next we'll go to the transfer dashboard. So in the transfer dashboard, which is the most critical part of this project, so total transaction is 474.46k count, and fraud cases are 1977 case, and the risk is 6507 level, and the average fraud probability is 3.20% in average, and transfer transactions have the highest fraud count in the entire dataset. The risk level distribution shows that 53.31% of the transfer transactions fall under the high risk category. The transaction type versus fraud chart clearly shows a large spike, confirming that almost all fraud cases come from transfer transactions. So the fraud probability by step chart again shows higher probability values compared to the other transaction types. In the recent transactions, you can see the count again and the amount and fraud cases and the probability. So here the probability is very high. This confirms that the transfer transactions are the primary source of the fraud in the dataset. So overall, transfer is the most crucial and critical and high risk transaction type, requiring strict monitoring and fraud prevention measures. So we can go to the withdrawal dashboard. In the withdrawal dashboard, you can see the transactions like 62.00k count, and fraud cases are 0 here, and the high risk is 1102 level, and the probability is 10.07%. Even though there are 0 fraud cases, the fraud probability is high. So this shows the risk level distribution also shows that 9.03% of withdrawal transactions fall under high risk. So this confirms that like the transaction type versus fraud chart confirms 0 fraud cases. The fraud probability which step that chart shows higher probability spikes similar to deposit transactions. So you can see in the recent transactions there are 62,004 count, and the amount and the fraud probability for the withdrawal transaction. So this overall withdrawal transaction shows high risk but 0 confirmed fraud, meaning they require monitoring but not as dangerous as transfer transactions. So to conclude this Power BI fraud analytics dashboard, which provides a clear understanding of transaction behavior and fraud patterns. Transfer transactions are the major source of the fraud. Deposit and withdrawal show high risk but no confirmed fraud. Debit and payment are the safest categories. So this dashboard can help financially institutions monitor suspicious activity, prioritize high risk transactions, and improve fraud detection strategies. Thank you.